Welcome back, geometry students, to another Regents review video. This is the Geometry Common Core Regents exam for August 2017 of this particular administration. These are going to be the solutions to parts 2 through 4. The reason why I just got so quiet is that these are by far, as of today, which I'm filming this in the month of January of 2018. Who knows if it will get harder? These are the hardest part 2s, 3s, and 4s ever given on a geometry Regents I've ever seen in my life. And you'll see the last question, you're gonna blow your brains. That will take me at least 20 minutes to explain to you. Now, with that being said, if you are here to copy my answers, you are so in the wrong place and you should not be here. Make sure that you actually try the problems by yourself, or if you are in total confusion, then you have come to the right place, or if you're here to check your answers. But if you are here to copy my answers, you are so wrong. You gotta do the work, please. Make sure that you hit that subscribe button down below. Consider becoming a Patreon to keep this channel going, because I do put my own money into this service, so it'd be nice to just have some patrons on Patreon just to help me get through my financial difficulties. Make sure you visit my website at www.nysmathregentsprep.com for a lot more math content in geometry and further math subjects. And let's just jump right to the part 2s. Right to the part 2. This is going to be a long video. I kid you not. So the first question, right out of the freaking gate, this was not a repeat question, but it was a question similar to the June 2017 Regents exam. Again, they're testing your knowledge on Cavaliers Principle without even saying Cavaliers Principle in the question. Let's talk about it. Sue believes that two cylinders shown in the diagram below have equal volumes. Is Sue correct? Explain why. So the first thing that should pop into your head is that one of these is a cylinder, one of these is an oblique cylinder. An oblique means that it's slanted in some way, shape, or form. So she's saying these definitely take up the same amount of space. Don't forget that volume means the amount of space it takes up. Okay? Does it? Well, we got to figure that out. So, to prove Cavaliers Principle, you need to do one of two things. The first thing that you need to do is prove that the bases of the prisms are equal to each other. Then you need to prove that the heights are equal to each other. Well, let's do this now. Let's find the area of this circle down here, because this is a circle. So the area of the circle in, let's call this prism A and let's call this prism B. The area of circle A is equal to pi r squared. Okay, that's the area of a circle, pi r squared. The area of circle A is equal to pi. The radius is 5, and you square it. The area is 25 pi. I'm not going to type that into my calculator. I'm just going to leave it as is. The area is 25 pi. Okay? For prism B, on the other hand, let's take a look. The area of circle B is equal to pi r squared. The area of circle B is equal to pi. Now, the diameter is 10. The radius is 5. So we get 5 squared. This is, again, 25 pi. Okay, so far we're in the running that these two volumes are equal. So, that the areas are equal. Are the heights equal? 11.5, 11.5. Don't be fooled by the 12. Don't be fooled. Don't be fooled. It is the vertical height that they're talking about, not the slant height, the vertical height. And they are. They're equal. We're happy because the volumes are equal according to Cavaliers Principle. So, your explanation in words is this. Due to Cavaliers Principle, if two prisms are the same height and have the same cross-sectional area at every level, then the volumes are equal. So yes, Sue is correct. And that's it. That's how you answer that question. We explained what Cavaliers Principle was. We gave a yes that Sue is correct. We got the full 2 points. Run with it. We're good to go. Number 26. This is the simplest part 2, in my opinion, out of them all. In the diagram of rhombus PQRS shown, the diagonals PR and QS intersect at point T. PR, the length of PR. All right, so the diagonal PR, let me get a highlighter here. The diagonal length of PR is 16. And the diagonal length of QS, well, that has a length of 30. Okay? Now it's saying here, determine and state the perimeter of PQRS. So what you need to remember about a rhombus is that they form right angles in the middle, or the diagonals form right angles because they're perpendicular to each other. So what does that tell you? It tells me that these are 4 right triangles here. 1, 2, 3. There's 4 right triangles in this diagram. So, and in addition, the diagonals bisect each other. So this is congruent to this, and this is congruent to this. So if this whole length is 16, that means that this is 8 and 8. And if this whole length is 30, that means that this is 15 and 15. Well, what we could do from here, which is pretty sweet, is we could apply Pythagorean's theorem to one of the triangles and get the length of the hypotenuse, then just multiply that number by 4. Let me explain why. The four sides of a rhombus are congruent to each other. This is a right triangle. If we're given 2 legs of a right triangle, we could solve for the hypotenuse by using the Pythagorean theorem, which is a squared plus b squared is equal to c squared. So I'm just going to take the 2 legs, which is 8 and 15. I'm going to square them both, and that equals c squared. Okay? So we get 64 plus 225 equals c squared. 64 plus 225 is 289 equals c squared. Take the square root of both sides. We get that c is equal to the length of 17. So this one side of the rhombus is equal to 17. Since a rhombus, they tell us that it's a rhombus. Since the rhombus has 4 congruent sides, we just take 17 and multiply it by the number 4. Your perimeter is 68. This, ladies and gentlemen, is your answer. The perimeter of the rhombus is 68. Okay, that's how you do that question. Not too bad. 27. All right, this transformation looks a little wacko. Quadrilateral math and its image, quadrilateral M double prime, A double prime, T double prime, H double prime, are graphed on the set of axes below. Describe a sequence, here we go again, sequence of transformations, meaning multiple transformations that would map quadrilateral math onto quadrilateral M double prime, A double prime, T double prime, H double prime. Let's take a look. Now, here's the thing, people. There are many answers for this question. I'm going to give you my answer, and if you want to take it, that's fine. If you want to confirm that your answer is correct, you could either email me or you could ask your teacher or anyone else that's good at math. So let's take a look here. We know for a fact that it's a rotation about something, but we got to be specific. A rotation about what point? The point, it looks maybe like the point negative 0.5, 0.5. That could work. Okay. What I personally said is I kind of went the easy way. I said rotate it 180 degrees centered at point H, meaning spin it around to translate it on in this vicinity, and then translate it to the left one, then up one. Okay? So my answer was a rotation of 180 degrees centered at point H, followed by a translation to the left one by 1 unit and up by 1 unit. which by the notation, it's a translation of negative 1, comma 1, will map math onto m double prime a double prime t double prime h double prime. And that, ladies and gentlemen, is how you answer that question. Again, there are so many other answers that you can use. If you want to just confirm, just ask me or your teacher. All right, moving on to question number 28. Oh, this is a construction question. Using a compass and straight edge, construct a regular hexagon inscribed in circle O. Leave all construction marks. Okay, so the first thing that I want to establish or to understand is that a regular hexagon means that all 6 sides, and there's 6 sides in a hexagon, all 6 sides are congruent. Okay? So I'm going to take my ruler or my straight edge, and I'm going to construct a radius from O to this endpoint. I'm going to call that endpoint point A. So now what your goal is to take your compass and place it on A, spin it around in intervals, draw your hexagon, and you're done. By the way, if you don't like what I'm doing on the computer, I have a hands-on construction immediately following this. So if you want to fast forward that, if you don't like it this way, that's perfectly fine with me. Or if you want to watch both, that's fine too. So here we go. What we're going to do is we're going to place our compass point on the radius, or sorry, the center of the circle, which is O, measure the length of the radius. We need that length. Now what I'm going to do is I'm going to place my compass point right on A, directly on A, and I'm going to construct my first arc. Then the next thing to do is place your compass point on the new intersection point, which is here, and repeat the process, like so. Do it again. And keep on going until you reach back to point A. Now, here's the thing. You should get back right onto point A. The chances of that happening are slim to none just because the human hand is so shaky. So let me just tell you that it's normal if the compass goes a little bit further or less than what it's supposed to. That's okay as long as you get the right idea. And see, I have a feeling that it's going to go over. And it is. It's going to go over. That's an acceptable error. Honestly, though, if you get that, I would honestly just fix it. And I know how to fix it just because I've been doing this for a while. But I know how to fix my arc measurements, so I could do it. Oops, I could do it just like this. So I have the capabilities of just moving my little tick marks. You need to redo the thing. So I know for a fact that this is correct. All 6 sides are congruent. Draw your things. 1, 2, 3, 4, 5, 6. Just use it with the straight edge, and you have your regular hexagon. And that's how you do the construction. For the next thing, you'll see more hands-on construction, and we'll go on to the next question after that. All right, so here's question number 28 on the August 2017 administration of the geometry regions. This is just a hands-on construction. Here we go. Number 28 says, using a compass and straight edge, construct a regular hexagon inscribed in circle O, leave all construction marks. So it's just the same procedure as before. In order to construct a regular hexagon, meaning that all 6 sides are congruent, the first thing that we need to do is indicate a point on our circle, and I'm going to call this one way over here. I'm going to call this point A. And that's just calculated by drawing any radius from point O to the outside of the circle. So that's just our radius to work with. Now what we need to do is take your compass, any type of compass would do. Take your compass, place it on point O, and measure the length of the radius. Just like so. Now once we get the length of the radius, you're then going to take your compass point and you're going to place it right on A, and you're going to measure like so. Okay? So once we measure this, now we just continue the process. Place your compass point on the new intersection point right here, and we're just going to continue the process all the way around. Now it should be lined up perfectly on your sheet of paper, meaning that the point of the compass should line up perfectly in the center of the intersection point, or else you will be off by a few centimeters. All right, so continue the process all the way around, and you should come right back to point A. And in this case, I am lucky enough to come very, very close to point A. So now all we need to do is just take a straight edge and take our pen and just draw or connect the dots of the intersection points. So from here, we could just draw all the way around, like so. Now, after you draw those lines, it would be beneficial just to label all of your points, but it's really not necessary. So if you would like, you could label this as A, B, C, D, E, and F if you want to be very specific. And that is how you do that question. All right, here's question number 29. The coordinates of the endpoints of line AB are A 2, 3, and B 5, -1. Determine the length of A prime B prime, the image of AB after a dilation of 1/2 centered at the origin. Okay, we got a problem here, folks. We're not given the length of line segment AB. So what we got to do is we need to say, hey, we're smarter than New York State. We need to calculate the distance between points A and B. So let's go ahead and calculate the distance between A and B. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So now what we're going to do is we're just going to take these coordinates and plug them in. So d equals the square root of 2 minus 5 squared plus 3 minus a -1 squared. D equals the square root of -3 squared plus 4 squared. This is d equals the square root of 9 plus 16, which is the square root of 25, which is equal to 5. So it just says determine the length of A prime B prime, the image of line AB after a dilation of 1/2 centered at the origin. So this is easy. We got the length of AB, so I'm just going to say my answer. The length of A prime B prime is 5/2. Does it say justify anywhere? No, you're done. The length of A prime B prime is 5/2. All you're doing is you're taking 5 and you're multiplying by 1/2, which is just 5/2. If you put 2.5, that's perfectly fine as well. So 5/2 or 2.5, either one of those answers would be perfectly acceptable for this question. All right, that's question number 29. Pretty simple stuff. Number 30. In the diagram below of triangle ABC and triangle XYZ, a sequence of rigid motions maps angle A onto angle X, angle C onto angle Z, and AC onto XZ. Determine and state whether line segment BC is congruent to line segment YZ. Explain why. Okay. Do you think that those two line segments are congruent? And if you're saying yes, you are absolutely correct. But you need to get the right reasoning. These two triangles, excluding this, because they asked us that information, excluding this, look at what we have here. We have an angle, a side, and an angle. Angle, side, angle. These two triangles are congruent by angle, side, angle. So if we have triangles that are congruent already, we could prove anything else to be congruent by CPCTC, which stands for corresponding parts of congruent triangles are congruent. So determine, state whether that is congruent. Explain why. Yes, BC is congruent to YZ. Triangle ABC is congruent to triangle XYZ by the angle, side, angle, triangle congruency postulate. You don't have to say that, but you could just say that they're congruent and leave it at that. But you need to say that they're congruent by angle, side, angle. I'm just putting those words afterwards. Okay? Then we could say that BC is congruent to YZ by CPCTC, which again stands for, if you don't know, corresponding parts of congruent triangles are congruent. And that's how you prove that. Pretty basic question. I didn't think it was that bad. Could have been worse, but that is all you had to do for that question. Okay, this was a rare question just because it was a part 2. It's usually a multiple choice. So you actually have to know what you were doing and show your work. Number 31 says, determine and state the coordinates of the center and the length of the radius of a circle whose equation is x squared plus y squared minus 6y equals 56 minus 8y. Oh, we got some problems here, folks. We need to take this form. This is called general form or standard form. It's general or standard form of a circle. We want this in center radius form. And if you don't know the center radius form of a circle, it's this. X minus h squared plus y minus k squared equals r squared. Well, why would we want that? Because we could actually easily determine the center and the radius in center radius form, hence the name. So what we're going to do is we're going to perform an operation or a method called completing the square. You learn this in Algebra 1, and I told you in Algebra 1, if you watch those videos, if you were watching my Algebra 1 videos when you were in Algebra 1, now you're in Geometry, completing the square comes back to bite you in the butt. And make sure that you remember completing the square for next year in Algebra 2, because you're going to see it again on the Regents exam. So completing the square. I always tell students, keep letters on one side, numbers on other. So what we got to do is we got to take that negative 8y, which is bugging me, and you got to move it over there. Okay? So this immediately becomes the following. Let me just change the color here. Make it look nice. Okay, fine. This becomes x squared plus y squared minus 6x. Move that negative 8y over. This becomes positive 8y equals 56. Okay? So from here, what we're going to do is we're actually going to perform completing the square. What you need to do is rearrange or shuffle up the letters on the left-hand side of the equal sign. So, for example, the x's go with the x's, the y's go with the y's. So we get x squared minus 6x plus something plus y squared plus 8y plus something equals 56 plus something plus something. Now, wait a minute. You're like, Trevor, where did you get these blank space from? I don't know what you're talking about. Well, this is what we got to do. What I just did is I just rearranged the x's together and the y's together. Your goal is to acquire a perfect square trinomial to express it in center radius form. In order to acquire a perfect square trinomial, you need to add a constant term to both of the groupings. And in order to get this, and you should have learned this again in Algebra 1, to get this, you have to use the classic formula, which is b divided by 2 squared, which that means take half the middle and square it. So take a look at this one. The middle term is negative 6. Take negative 6 divided by 2, which is negative 3. Negative 3 squared is 9. Put the 9 over here, put the 9 over here. What do you do to one side of the equation? You must do to the other side of the equation. This is all Algebra 1. So take this one. The middle term is 8. 8 divided by 2 is 4. 4 squared is 16. 16, 16. Boom. Now, this is where most people honestly get stuck. Right here. They don't know what to do from here. Some people get up to this point, they're like, all right, now what do I do? Well, that's perfectly normal if you are having trouble. The next thing to do is to factor. Remember, you need to factor to get your center radius form. What do I mean by that? Well, you need to take this and factor by the AM method. Take this, factor by the AM method. Remember what AM means. What adds to the middle number multiplies to give you the constant number. So, what adds to negative 6 but multiplies to give you positive 9? Well, that's just going to be x minus 3, x minus 3. Pretty simple so far. Then, in this case, what adds to 8 and multiplies to give you 16? Well, we're just getting y plus 4, because 4 times 4 gives you 16, 4 plus 4 gives you 8, and over here, negative 3 times negative 3 gives you positive 9, negative 3 plus negative 3 gives you negative 6. And if you haven't realized by now, completing the square, you get the same factor twice. And if you don't, you know you did it wrong. Okay? And when you add this on this side, this will give you 57. This will give you 81. Okay? So now what I'm going to do is I'm going to group these into a condensed piece. I could rewrite this as x minus 3 quantity squared. I could write that with just a square, that 2 representing that you could write this twice. Plus y plus 4 quantity squared equals 81. Doesn't this look a lot like the top equation that I wrote before, the center radius form of a circle? That was your goal. So now what we got to do is, we're not just leaving it there. It says determine and state the coordinates of the center and the length of the radius. We're almost there. The center of the circle is you're taking the opposite values of what you see here. The negative 3 and the positive 4. The center is positive 3, negative 4, and your radius is the square root of 81, which is the number 9. Ladies and gentlemen, that is your answer. The center is 3, negative 4, and your radius is 9. And that is how you do that question. Not too bad of a question. It was just a part 2 this year. All right, moving on to the part 3s. Here we go. Triangle PQR has vertices negative 3, 1, negative 1, 7, and 3, 3. And points A and B are midpoints of PQ and RQ, respectively. Use, oh man, they were nasty here, weren't they? They specifically say use coordinate geometry to prove that AB is parallel to PR and is half the length of PR. The set of axes below is optional. Here's the thing. When they say coordinate geometry, you need to use coordinate geometry formulas, such as the midpoint formula, the distance formula, the slope formula. All of those things are a part of coordinate geometry. So, here's what I'm going to do first. I am actually going to graph these points. I'm going to graph the point negative 3, negative 1, negative 1, 7, and 3, 3. P, Q, R. Great. So I'm just going to connect those dots. There we go. Okay. Now it says points A and B are midpoints of P, Q, and QR respectively. Okay. We have to calculate those midpoints. How do we do that? Well, you need to know the midpoint formula. The midpoint formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Okay? Now, to find point A, it says point A lies on PQ. So we have to find point A using the points P and point Q. So let's go ahead and do that now. The midpoint to find A is negative 3 plus a negative 1 divided by 2, comma, negative 1 plus 7 divided by 2. That gives you a midpoint. Let's see, negative 3 plus negative 1 is a negative 4, divided that by 2. Negative 1 plus 7 is 6 over 2. That gives you a point negative 2, comma 3. Okay? So if we go on the graph, negative 2, comma 3, what do you know? It lies perfectly in the middle of PQ. That is point A. Now let's calculate the midpoint, which is point B. Midpoint equals the following. Now we got to find R, or calculate the midpoint of RQ. So we get 3 plus a negative 1 divided by 2, comma, 3 plus 7 divided by 2. That gives you 2 over 2, 10 over 2. This results in 1, comma, 5. Graph it. 1, 1, 2, 3, 4, 5. That's point B. Perfect. So we know for a fact that we have the right midpoints. We're okay so far. Now what we have to do is we need to prove that AB is parallel to PR first. Let's go ahead and prove that they're parallel. And how do you prove that they're parallel? Parallel lines have the same slopes. So what you're going to do is use the slope formula on both of these to prove that they're the same. So let's calculate the slope of AB, which you should know by now that the slope formula is the change in y over the change in x, which is y2 minus y1 over x2 minus x1. That will give you 5 minus 3 over 1 plus 2. That will give you 2/3. Just watch out for your signs there. It is a plus in that case just because that 2 was negative. So the slope is 2/3 for line AB. Now let's calculate the slope of PR. Right, PR? Yep, PR. Let's do it. So the change in y over the change in x, that's going to be 3 plus 1 over 3 plus 3. Just watch your signs. You get 4 over 6, which reduces to 2/3. What do you know? Those slopes are the same. I'm going to leave that as is, and we're going to explain it a little bit later. Now, we just proved the parallel part. Now let's go to prove half the length of PR. So what we need to do is realize, wait a minute, if we're doing halves of things or find the length, doesn't distance ring a bell? Distance should ring a bell. So we're going to calculate the distance of AB. So D equals the square root. I'm just going to take the coordinates from AB and plug them in. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. D equals the square root of 1 minus a negative 2 quantity squared plus 5 minus 3 quantity squared. D equals the square root. This will give you 3 squared plus 2 squared, which is the square root of 9 plus 4, which is the square root of 13. Okay? Now we're going to calculate the distance of PR. Okay? D equals the square root. Take the coordinates again. We get 3 minus negative 3 quantity squared plus 3 minus a negative 1 quantity squared. D equals the square root. This will give us a positive 6 squared plus 4 squared. That gives us the square root of 36 plus 16. That's D equals the square root of 52. Now the problem is, folks, is you can't see it right away. You don't know that 52 is actually, the square root of 52 is actually double the length of radical 13. You need to simplify this radical by using your simplification rules of radicals. Make sure you remember from Algebra 1. Think of the highest perfect square that goes into the square root of 52. Well, that's just the square root of 4 and the square root of 13, because 4 times 13 gives you 4 times 13 gives you 52. Okay? The square root of 4, which is the highest perfect square in this case, is 2 radical 13. Oh, wait a minute. Radical 13, 2 times radical 13. Double, 2, double. So we just proved that this is double the length of that. Okay? So now we got to put all this into words. Let's go and put it into words. So I'm going to say that AB is parallel to PR because the slopes are the same, forming parallel lines. That's the first explanation. Then the second explanation is AB is half the length of PR because radical 13 is half of 2 radical 13. And that, ladies and gentlemen, is how you explain your answer. That was definitely a pretty long freaking problem. As you can see, very tiny text. But if you want to rewind and just make sure that you went through everything correctly, but that is how you do this entire question. Moving on to question number 33. Here's another doozy. All right, 33, this is a circle proof. In the diagram below of circle O, tangent EC is drawn to diameter AC. Chord BC is parallel to secant ADE, and chord AB is drawn. Prove that BC to CA equals AB to EC. We need to create a statement of reason proof. All right, so we'll just put that in there. Statements and reasons. Draw a 2-column proof. Again, as you can see, they don't give you the 2-column proof. You actually have to draw it in yourselves, which is kind of annoying. I wish that they did it for you, but people have different ways of proofs. Some people do column proofs. Some people do paragraph proofs. Some people do flow proofs. There's a bunch of different ways to prove things using methods. Okay, here we go. Enough of my babbling. So what I'm going to do is I'm actually just going to label the couple things that you need to know. So here we go. Let me read this again. Chord BC is parallel to secant ADE. Okay. And it also says that tangent EC is drawn to diameter AC. That means that this is a right angle right over there because a tangent is perpendicular to a diameter. And a tangent is also perpendicular to a radius. Okay? And also, since these lines are parallel, I could conclude that this angle over here is congruent to this angle over here because if parallel lines are cut by a transversal, the alternate interior angles are congruent. I'm just doing this to jog your brains here. Okay? And this angle up here, angle B, is also a right angle. But why is that a right angle? Because it is inscribed, this is an inscribed angle. This angle is inscribed inside of a semicircle. It intercepts a semicircle, which is 180 degrees, and since that is an inscribed angle, it's half of the arc it intercepts, which half of 180 is 90. That's why it is a right angle. A lot of stuff going on here. This is a hard proof, so you got to know what you're doing. I'm going to call this angle 1. I'm going to call this angle 2. I'm going to call this angle 3. I'm going to call this angle 4. Your objective is to prove this, but what on God's green earth does that mean? That basically stands for corresponding sides of similar triangles are in proportion. That's what that means. So you probably learned CSSTP. That's your goal. Corresponding sides of similar triangles are in proportion. Well, I said a key word there, similar. That means that you need to prove these two triangles similar. Well, what triangles am I proving similar? Well, I'm glad you asked. You are proving, give me a minute. You're proving this triangle to be similar to this triangle right over here. You're proving those two triangles to be similar to each other. By, what do you think you're proving it by? By angle, because we have two angles. We're not given side lengths. We have to use angles. That's why I was jogging your memory with all of those angle measures. Okay, without further ado, here we go. Number 1. Circle O. Tangent EC is drawn to diameter AC. Your reason? Given. Okay, number 2. I'm going to say that AC is perpendicular to EC, which that, folks, AC is perpendicular to EC. I'm proving that angle 2 is a right angle by the tangent diameter theorem. So, your reason for this is a tangent drawn to a circle is perpendicular to its diameter. Okay? Not too bad. Now we go on to number 3. I'm going to say that angle 2, what I just proved before, angle 2 is a right angle. Your reason? Perpendicular lines form right angles. Okay. Now we're getting places. We just proved one of the 4 angles that we need. Let's go on to step 4. Angle 1 is a right angle. Okay, so I'm going to say this up here, angle 1 is a right angle. Your reason? An angle that is inscribed within a semicircle is a right angle. Okay, we just proved angle 1 and angle 2. Now we got to say that angle 1 is congruent to angle 2, or else we're not getting places here. So we got to say, hey, angle 1 is congruent to angle 2. Your reason, the famous one that everyone knows, All right angles are congruent. Okay? That's that. Now, for number 6, step 6, we want to prove angle 3 is congruent to angle 4. Now, we just said in the given... No, we did not. I didn't say that in the given. Okay, so I split up my given. So I'm going to say in number 6 that chord BC is parallel to secant ADE. I'm going to say that chord AB is drawn. And that's all given information. That's the rest of the given information. Now, number 7. Angle 3 is now congruent to angle 4. Your reason? Here we go. Angle 3 is congruent to angle 4. If two parallel lines, and I hope that you devote this to memory because this is a common theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. Nice. Now we just proved all of our angles. Let's go ahead and say that these two triangles are similar to each other. So triangle ABC is similar to triangle ECA. Your reason is angle is congruent to angle. Last but not least, we're trying to prove that BC is in proportion to CA, which is equal to the proportion of AB divided by EC. Your reason is CSSTP, which again stands for corresponding sides of similar triangles are in proportion. If you want to slow down the video, you by all means go back and review it. But that, ladies and gentlemen, is the proof of that circle question. All right, we're almost done with the part 3s. We got to go into the part 4s, which is another hassle because the part 4s in this case are ridiculously long. Number 34. Kira? Yeah, Kira. I want to say Kira. Has a square poster that she is framing and placing on her wall. The poster has a diagonal 58 centimeter long and fits exactly inside the frame. The width of the frame around the picture is 4 centimeters. Determine and state the total area of the poster and frame to the nearest tenth of a square centimeter. Okay, so I don't like how the way that they phrase this question. Find the total area of the poster and the frame, as in you're finding the area of this whole figure. You're finding all of it. So what we got to do is we have to find the area of the poster first. Then we got to find the area of the frame. Add those up together and you got your answer. So, the poster. Look at the poster. The poster has 58 centimeters as its hypotenuse. Oh, whoa, wait. Where'd you get hypotenuse from? Well, that's a right angle. The reason why, it's a square poster. But wait, that tells me another thing. A square has 4 congruent sides. That means this is congruent to this. That's so important because we don't have the side lengths. I'm going to call this x and x. We are forced, ladies and gentlemen, to use the Pythagorean Theorem. So, to find the poster, to find the area of the poster, the first thing that we got to do is we have to find or calculate the lengths of the sides, okay, by using the Pythagorean Theorem of a squared plus b squared equals c squared, okay? X squared plus x squared, those are your legs. The hypotenuse is 58 and square it. 2x squared equals 3364 when you type that into your calculator. Divide by 2 on both sides, and you get x squared is equal to 3364 over 2. Just leave it as is. Take the square root of both sides, and you're getting an answer of x is approximately equal to 41.012. That is the length of one of its sides. So now we actually have to find the area of the poster. We don't have the area of the poster, folks. We only got one of the sides. Now the area of a square is length times width. That's the formula for the area of a square. So now the area is just the length, which is really just 41.012 times 41.012, because these two sides are congruent to each other. So the area is equal to, let's type that in, 41.012 times 41.012. Your answer, 1681.984. 1681.984. Okay? That's the area of the poster itself. Now what we got to do is we need to calculate the area of the frame itself. You know what? Even though that you could find the area of the poster, then find the area of the gray, and then add those up, there's actually an easier way. Believe it or not. I'm going to erase this, and I'll tell you why. And I just saw it too. Look at this. If we know that this side is 41.012, and this is 4, and this is 4 up here, the whole side is 41.012 plus 4 plus 4. That means one side of this adds up to give you 49.0122. That is this whole side right here, folks. That is this right down here. But wait a minute. Isn't the frame a square? Yeah, it is. So can't we just take this side length and multiply it to itself and get the total area? Of course we can. Let's do it right now. So the area of the whole thing, let's do it. Area equals 49.0122 times 49.0122, because the frame is a square. The area is equal to, when you plug this into your calculator, you get 2402.2 to the nearest tenth of a square centimeter. That's it. That's your area, folks. A equals 2402.2. That is the answer to that question. That honestly wasn't that bad. I caught that at the very end. Sorry about that. All right, now on to the part 4s. Oh, jeez. This is a long test. Okay. This is a statement reason proof, so I need to, again, do this. Reasons. Okay. So, we have statements and reasons. Right here. I'm going to make this a little bit smaller because that is gargantuan. 20 and bold it. That's good. Okay. So, I'm going to draw this. I'm going to go through this slowly. I'm going to go through it slowly because this is one BS question. It's not BS, but it's just long. Okay, number 35 says, Isosceles Trapezoid ABCD has bases DC and AB with non-parallel legs AD and BC. Segments AE, BE, CE, and DE are drawn in trapezoid ABCD such that angle CDE is congruent to angle DCE, AE is perpendicular to DE, and BE is perpendicular to CE. Could you actually believe that this is my favorite subject in my life? Like, this is what I love to do. I teach Algebra 1 and Algebra 2 just because I like that too, but geometry is my favorite math. Could you believe it? This is so much crap. Okay. Prove that triangle ADE is congruent to triangle BCE, and prove that triangle AEB is an isosceles triangle. Okay, that's a lot of information. Let's break it down piece by piece. The first thing that I want to talk about is isosceles trapezoid. Isosceles trapezoid means that DA is congruent to BC. And it also means that angle D, the whole thing, is congruent to angle C. Okay? Then it says that, okay, well, it's a trapezoid. So that means that this side, DC, is parallel to side AB. Okay? And then it tells you that the measure of angles CDE, so this little guy in here, is congruent to this little guy over here. And we also know that AE is perpendicular. AE is perpendicular to DE, and BE is perpendicular to CE. So there's a lot of stuff going on here. So the first thing that we got to prove is to prove that triangle ADE, which is here, is congruent to triangle BCE, which is over here. Okay. Then we got to prove that triangle AEB, which is in here. I use a horrible color. Hold on one second. Let me use yellow. Yellow's a little bit easier. We need to prove that this triangle is congruent to this triangle. And then we need to prove that this triangle in here is isosceles. Oh, that's a lot of work. Okay, so let's take a look at the yellow triangles first. What's our plan? What's our plan, folks? I only see a side, and I only see an angle. And that's a right angle, and this is a side. Okay, so here's the thing. You see this triangle DEC? This is an isosceles triangle, so therefore DE is congruent to E. Okay, so now I see two sides and one angle. The problem is angle, side, side. Really? I could use that? Absolutely not. No S's in class. So immediately, since you know that you have a leg and a right angle and a hypotenuse, you could use hypotenuse leg. This is the only, I'll say it again, this is the only way that you could prove these two yellow triangles to be congruent. If you used side, 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 angle, or angle, angle, side, you got it wrong. You have to use hypotenuse leg. There's no other option for you. Okay, actually, I'm sorry. Actually, there is another way. You could use angle, side, angle. Would you do it? I wouldn't, because then you have to use the subtraction postulate, which is, don't do it. Don't do it. Don't do it. It takes forever. So, okay, hypotenuse leg, or you could use angle, side, angle. Fine. But this is the more tedious way, angle, side, angle. You have to, hypotenuse leg is the easiest way to go. Here we go. Enough of my babble. Number one, I'm going to write the givens. Here we go. Isosceles trapezoid. A, B, C, D. Has bases DC and AB with non-parallel legs AD and BC. Segments AE, BE, CE, and DE are drawn in trapezoid. ABCD, such that angle angle CDE is congruent to angle DCE. AE is perpendicular to DE, and BE is perpendicular to C. That's a lot of freaking given information, but you need to write it down in full, or else you don't get credit. So that's all given. Now what I'm going to say here is I'm going to say that triangle DEC, which is right here, is isosceles. And you'll see why in a moment. So I'm going to say that triangle DEC, that looks like an O, is isosceles. Your reason is, well, we have two congruent base angles, the red ones. So we could say that if two angles are congruent in a triangle, then it is isosceles. Okay, that's easy. Now I'm going to say number 3. I am now going to say that, do I even need to say that? EDs. Yeah, you could say it. you can say that DE is congruent to EC. And your reason is definition of isosceles triangle. Very rarely do I write definition of, but this one is definitely a go-to for definition. All right, number 4. Now we're going to say that angle 1 and angle 2, which I need to label here, angle 1 and angle, see, these are angle 1 and angle 2. 1 and 2. Angle 1 and angle 2 are right angles. Your reason? Perpendicular lines form right angles. Number 5. We're going to say now that angle 1 is congruent to angle 2. Your reason? All right angles are congruent. Number 6. I am now going to say that, let's see, AD is congruent to BC. These are the two hypotenuses that you see over there. And you'll know why that is, because it's an isosceles trapezoid. So, definition of isosceles trapezoid. Okay? Number 7. I am now going to say that these two triangles are, in fact, right triangles. So I'm going to say that triangle ADE and triangle BCE are right triangles. Your reason? Definition of a right triangle. Now, the definition of a right triangle is a triangle that contains one right angle. Okay? Definition of right triangle. Number 8, your reason, your statement, triangle ADE is congruent to triangle BCE. Your reason is hypotenuse leg is congruent to hypotenuse leg. And if you're wondering whether or not you need step 7 and reason 7, yeah, you do. You need to say this or else you can't prove by hypotenuse leg. You need to say somewhere in your proof that it is a right triangle first, and then you go ahead and use hypotenuse leg. Now that's over with, thank God. So now on to number 9. I am going to say, because now the next piece is to prove that this is isosceles. Now to prove this to be isosceles, we need 2 pairs of corresponding sides to be congruent. AE is congruent to EB, folks. Why is that? Well, AE is congruent to EB by CPCTC. Corresponding parts of congruent triangles are congruent. If you prove triangles to be congruent, you could prove all of the other corresponding pieces of that triangle to be congruent to each other. So, that's true right here. Now for number 10. I'm going to say that triangle AEB is isosceles. And your reason? 2 congruent sides in a triangle proves it to be isosceles. And that, ladies and gentlemen, is how you do that proof. Not that bad of a proof. Again, could be a lot worse, but I think that was a long and tedious one. You really had to know your properties of trapezoids. Now, ladies, gentlemen, boys, girls, teachers, faculty, parents, students, everyone who's watching this video, what you're about to witness is the most difficult part 4 question on the geometry Regents ever given. What is this? This is a pool that I wouldn't want to swim in because it's mathematically stupid. But let's go ahead and go through this question and let's try to make sense of it. I think, personally, if you know what to do, I think it's the biggest piece of cake on the face of the planet. But if at first glance, you're like, oh God, like you want to like throw up, like it's bad. Let's take a look and see what the question is asking us to do. A rectangular in-ground pool is modeled by the prism below. The inside of the pool is 16 feet wide and 35 feet long. The pool has a shallow end and a deep end, with a sloped floor connecting the two ends. Without water, the shallow end is 9 feet long and 4.5 feet deep, and the deep end of the pool is 12.5 feet long. Okay. If the sloped floor has an angle of depression of 16.5 degrees, what is the depth of the pool at the deep end to the nearest foot? Oh, sorry, tenth of a foot. So I want to talk about this right here. It's saying, what is the depth of the pool at the deep end? In other words, it's asking you to find the depth of, it's really English there. How far down is the deep end? That's basically what it's asking you. It's asking you to find this, or it's pretty much the same thing because, you know, it's a rectangular box. So unfortunately, there's no specific way to solve for this using any, like, you know, volume formulas or anything like that. You actually need to use dissection. What do I mean by dissection? Dissection means that you have to break down this figure into baby pieces. Let me explain why. Let's say, all right, so I'm going to actually to extend this dotted line here. I'm going to extend it over here. I'm going to extend it over here as well. Watch what I'm doing here. And this is quite, in my opinion, it's pretty cool. Listen, I really do think it's a cool question. I do. But on a Regents, I'm sorry, you shouldn't be putting this on a Regents exam. So, by dissection, you need to dissect this pool by the following. You need to make this a gigantic rectangular prism. You see the top layer here? It's kind of like a cake. You see the top layer? I'm making this pink. This is a rectangular prism. We know how to work with boxes. This is a big box. Are you kidding me? Thank you. This is a big box. This down here is a smaller box. We know how to work with small boxes. Pretty simple so far, right? Not too bad. Okay. Now, the problem is, what is over here? This is a triangular prism. This is a triangular prism. Okay? You see what I'm trying to do here? I'm cutting this into a big rectangular block at the top, and I'm slicing this at the bottom into a triangular prism and a rectangular prism. So here's what we got to do. Find the depth of this. Okay. So the first thing that I need to do is I have 4.5 feet. I know that a portion of this is 4.5. I'm missing this, the bottom of it. Well, the bottom of that is right here as well. That matches this, which matches this. Well, the problem is we don't have that at all. All we got is a freaking triangle here. Well, what do? This is what we do. We are going to be using trigonometry to solve for that side. I think I have a copy of it. Okay, hold on one second. I'm going to take a copy of this and I'm going to overlap it real quick, just to zoom in what I'm talking about here. Your goal is to solve for this right here. The problem is we only have an angle. We don't even have a freaking side. How are we dealing with this? You need to be smart about it. They tell you that this is 9 feet. They tell you that this is 12.5 feet. They tell you that the whole length is 35 feet up here. You see how mean this question is? You need to get this length, the blue line right there, by taking 35, subtracting 9, and subtracting 12.5 feet. Okay? So this line right over here has a length of 13.5 feet. Now we could use trigonometry SOHCAHTOA. Let's do it. So, we're trying to find this. I'm going to call that x. We're using SOHCAHTOA. This is the opposite. This is the adjacent. This is a right angle over here. This over here. This is the hypotenuse. We're not working with the hypotenuse. Sine and cosine are out. You are using tangent. So, let's solve for x. The tangent of 16.5 degrees is equal to the opposite side, which is x, over the adjacent side, which is 13.5. we are going to cross multiply this. 13.5 tangent of 16.5 equals x. Go to your TI Inspire graphing calculator. Type it in. 16.5 tangent. Oh, I'm sorry. 13.5 tangent of 16.5. Come on. 3.99888. Okay, so x is equal to 3.99888. Now it's saying find the depth of the pool. So we're just taking this, the 3.99888, and we're adding it to 4.5 to get the whole deep end. So we are just going to add 4.5. The deep end is equal to, when you add those up and round it to the nearest tenth, you get an answer of 8.5. So the deep end of this pool is 8.5. And I hope that makes sense. Did I just delete? Ah, I knew it. I deleted the marker in the back. Whatever. That's fine. Okay, so that's that. The deep end is 8.5. Now let's go on to the next thing. Find the volume of the inside of the pool to the nearest cubic foot. So what we got to do is we got to use that 8.5 to our advantage now. And we just found that x value. Hold on a second. Let me zoom in here. We just found that height right over here to be, what was that before? 3.99. I need to make this thinner. This is 3.99888. And this over here, this is 13.5. You see how disgusting this question is? I think it's horrible, but I think it's so good at the same time. So let's go ahead and find the volume of the pool. How do we find the volume of the pool? What I just said before, dissection. We are dissecting this. So we are dissecting this with the green up top. We're dividing this into a prism or a rectangular prism. Then we are using the bottom piece, and then we are using this triangular prism in here. You can't even see it. How am I gonna? Hold on, people. I'll make this blue. Make this green, because the green actually overlaps. I don't know why. And I'll make this let me make this a different color. Let me make it orange. Oh, that's a better color. Okay. There it is, okay? So we're breaking it down. So, we need to calculate the volume of the large rectangular prism, which is the box. Then we need to calculate the volume of the triangular prism. Then we need to calculate the volume of the smaller rectangular prism. Okay. The volume of the large prism is just the formula length times width times height. Okay? I'm going to put this in blue because it's in blue. So the length, they tell us, is 35 feet. The width is 16 feet. The height, okay, be careful here. The height is 4.5 for the blue piece. We're not talking about 8.5 here, folks. They just wanted us to find it. Whatever. But we don't even use it. I don't think we use it. We don't even use 8.5 in the problem. Whatever. So, what? Who cares? The volume of this is 2520. I'm not typing that into my calculator. Just take my word for it. The volume of the triangular prism. The volume of a triangular prism is calculated by capital B times the height, where capital B is the area of the base. And the base is a triangle. A triangle has the area formula of 1/2 base times height. So, we have 1/2. The base is 13.5, what we found. And the height is 3.99888. Multiplied by the height, which is this, which is tricky. It's pretty tricky. It's 16. The height, if you were to take that and just stand it up, the height is right there. The 16 up here. Okay? So now, when you go ahead and solve that, you get the volume as 431.8792. I should have put that in green. Forgive me. Green. Beautiful. Okay. Now the volume of the small, which is an orange, the volume of the small is still length with height. Length times width times height. Okay. The length of this is 12.5. The width is 16. And the height is, again, 3.99888. It's not even 8.5 because we're talking about the small piece. It's not 4.5. It's the height underneath it. So 3.99888. So the volume for this one is 799.7764. Now what you got to do is you got to add up all of these to get the volume of the pool. I'll just tell you right now, the total volume, because I'm lazy, the total volume is equal to 3,752 feet cubed. You don't need to put the units, but I do anyway. And that is if you round it to the nearest cubic foot. Are you kidding me? And if you think you're done yet, there's another part to this question. I can't anymore. A garden hose is used to fill the pool. Water comes out of the hose at a rate of 10.5 gallons per minute. How much time to the nearest... Oh, of course, you need to convert things, right? How much time to the nearest hour will it take to fill the pool 6 inches from the... Oh, God. 6 inches from the top. Are you freaking kidding me? So, they don't even want the pool filled all the way. So, what you need to do, or know, is you need to draw yet another... Yeah, you need to draw another prism from the top, but this time the height is 6 inches. But the problem is inches is not the same thing as feet, so you need to know that there are 6 inches in half of a foot. Great. So this is 0.5 feet. Whatever. So there are 5 steps to figure out how much time you're finding to the nearest hour, how much time it takes. So, step 1. Find the volume of air. It's literally air. Find the volume of air 6 inches from the top. So, but what's nice is it's still a rectangular prism. So the volume is still length with height, except this time it's just a length of 35. Oops. It's just a length of 35, a width of 16, and now just a height of 0.5. 0.5 is just 6 inches converted into feet. You get 280. That's the volume from the top. 6 inches from the top. Here we go. Step 2. Subtract the volumes. What do I mean by that? I'm saying subtract the volume from the whole thing, which is 3752, and subtract the air. So, 3752, which is the volume that it could hold, the pool could hold at its maximum capacity, subtract 280, you get 3472. Ladies and gentlemen, this is your total volume of water. That's how much water is going to be in the pool because the owners don't want to overflow the pool. By the way, if you fill it to the top and if you jump in, there's water's going to go all over the place. So they want it only to be filled to that capacity of the pool. Now, step 3. Find the amount of gallons. Yeah, okay. So this is currently in feet cubed. And again, they don't tell you this for no God-given reason. They gave that to you for a reason. 1 cubic foot is 7.48 gallons. Yeah, okay, great. This is in cubic feet. What your goal is to just take 3472 and multiply it by 7.48 gallons, and this will give you a total of 25,970.56 gallons. This is how many gallons are going to be in the pool. That's how many gallons are going to be in the pool. Then, step 4, you're going to find the amount of gallons per minute. As in, how many gallons can be pumped into the pool per minute? No, I'm sorry. Find the amount of gallons per minute. Is there a 10.5 here somewhere? 10. Yeah, okay. So Okay, so basically it says at a rate of 10.5 gallons per... All right, so we know that the rate is 10.5 gallons per minute. What our goal is to find the amount of minutes. That's what I should have said. Find the amount of minutes that it takes to fill the pool. So the amount of minutes is 25,970.56 gallons divided by the 10.5 gallons. That converts it to 2,473.3866 minutes. This is how many minutes, ladies and gentlemen, it takes to fill the pool. But they want it, of course, in terms of hours, because I don't know how many hours that is. So it's just easier to express it as hours. So you just take 2,473.3866 and divide it by 60, because there's 60 minutes in 1 hour. This will give you a total. It's rounded to the nearest hour of 41 hours. That, ladies and gentlemen, is your answer to that question. Okay. I hope that you enjoyed, or maybe not, but if it was helpful, please hit that like button down below. I know it was boring, but that you got to get it done. I hope that this was helpful. Make sure you hit that subscribe button down below. Please consider supporting me on Patreon, just because I'm doing this for no charge, but if you would like to help me out a little bit, you could definitely become a patron at Patreon. Make sure that you visit my website at www.nysmathreadersprep.com for a lot more math content in geometry and algebra 2 and many more math subjects to come, and I hope to see you soon.